We have the honor today to have together with us Professor Enrico Rettore for his keynote on impact evaluation. Professor Rettore has been cooperating with INVALSI for many years, and I even have memories of the time in which I was working with INVALSI 10 years ago, and he was supporting us in the assessment or of the analysis and review of the first big randomized controlled trial that we did in INVALSI concerning the Macabre project, and then innumerable support helps after that. Today, Professor Rettore will give us an introduction on the challenges concerning the measurement of causal effects of an intervention. And without further ado, I ask Enrico to get to the podium and help us. Thank you, Enrico.
Good morning and many thanks for this opportunity. So this is about the challenge. I'm just explaining in a moment what I mean by challenge of measuring the causal effects. David Azzolini here in the room contributed a lot to developing these set of slides based on our common experience in evaluating public intervention at FDK here. So what do we mean when we say causal effect of an intervention? So let's start from the very beginning. So the intuition here is very simple. The intervention bears a causal effect if it makes something happen. And that something would not happen in the absence of the intervention. Keep what we have in mind when we talk about the causal effect. So these ideas, think of this very simple example. Suppose you introduce a new way of teaching math in primary school, for instance. So this new way of teaching is in operation all over the school year, one school year, and by the end of this experience, you measure the performance in math of the students exposed to the new way of teaching. And suppose you have a score in a scale of 1 to 10, and on that scale, the average is 7, say. So we say that the intervention has a positive causal effect of math performance if, in the absence of the new method, so using the standard method, the average value would have been lower than 7. So this is a very simple, intuitive way of defining the causal effect. It is based on a thought experiment. What we are doing is comparing the factual outcome of students after the intervention to their counterfactual outcome. That is what we would have observed in the absence of the intervention. So factual here means observable. Counterfactual, I'm sorry, means unobservable. And being unobservable, the counterfactual, okay. Being unobservable, the counterfactual, it is clear that we have a major problem when we switch from the logical definition of causal effect to the operations. Because how do we measure the counterfactual? It is clear how to measure the factual outcome, but how do we measure the counterfactual outcome? Where do we find the students' math performance, in my previous example, where they're not exposed to the intervention? So it is immediately clear that all we can do is replacing the unobservable, the counterfactual, by the factual, the observable outcome of a suitable group of students not exposed to the intervention, students learning math using the standard model. So suppose the math performance of this group of unexposed students, suppose it is on average as large as 6. So on the one hand, we have students with the new method averaging at 7. On the other hand, we have a group of students under the standard model averaging at 6. Is that difference an estimate of the causal effect of intervention? In general, it is not. Because the question is whether the unexposed students under the standard model, whether they provide a credible approximation to the counterfactual outcome of those under the new model. And of course, the direct check of the quality of this approximation is unfeasible because the counterfactual outcome of the treatment group, those exposed to the new model, it is not observable. So how do we proceed to select, in practice I mean, to select a suitable group of non-exposed students? Here is the challenge alluded to in the title of this communication. And the key word is designing the evaluation. Designing always means, designing the counterfactual evaluation, always means identifying a proper comparison group, a proper group of individuals not exposed to the intervention under evaluation. So it is, by designing, I mean a systematic attempt to make the two groups, those under the intervention and those not exposed to the intervention, as similar as possible with respect to everything but exposure to the intervention, of course. So what we do in practice, it depends on the degree of control the evaluator has on the selection process. The selection process is simply the reason or reasons why some individuals end up receiving the treatment being exposed to the intervention and the other group not receiving the intervention. So how did it happen? So the key question is whether the evaluator is in the position or not to decide, to choose who will be exposed to the intervention and who will not. So if the answer to the question is yes, it is the evaluator to decide, then there is room for implementing the so-called randomized control trial. If the evaluator is unable to decide, all we can do is an observational study. So I'm reviewing very briefly the key steps of the two possible solutions. So randomized control trial, the idea is extremely simple. So what you do is that you recruit a set of individuals for your study, and then you split the pool of individuals, available individuals, into two piles. And you do that literally at random, so tossing a coin. So it is, random selection is, strictly speaking, a sort of lottery, no more than that. And the key point, the key mathematical property of random selection is that it makes sure that the two groups are, on average, equivalent in all respects. The first implication of this equivalence on average is that if both groups were denied the intervention, sono 1 exposed to it, then they would be, on average, equivalent also with respect to their final outcome, because there is no reason to find a difference in the final outcome. But if the two groups, in the absence of the intervention, the two groups would be equivalent with the outcome, what we can do is simply to replace the unobservable counterfactual of participants by the factual of non-participants, because we know they are equivalent. Oh, there are a couple of qualifications here. So first one is that both groups, from now on, capital T means treatment group, capital C means control group. They must be sufficiently large. This is the key, the important point from a statistical point of view, because even if you are, I told you that they are equivalent on average, right? But by chance, only by chance, there might be differences between the two groups. So the only way to reduce that difference due to chance is to have an acceptable size, an acceptably large number of units, both in the treatment group and in the control group. So there are some simple statistical rules to determine the size of the two groups, but I'm not going to the technical details here. But the rule of thumb is very simple. The larger, the better, of course. The second qualification is that the two randomly selected groups, as I told you, are equivalent on average. And the implication is that by comparing the two groups, what we discover is the average causal effect of the intervention. So it is no way of discovering the causal effect of intervention on each single individual recruited for the study. And what that average hides, as usual, is the heterogeneity of the causal effect. So there are important policy questions. Are there individuals gaining more than others from the intervention? Are there individuals hurt by the interventions? So it is clear that they are important questions. And partial answers to those questions are available, indeed. But again, what is really important is that the number of units in the study should be large, in particular if you want to explore the heterogeneity of the causal effect. So the RCT, randomized controlled trials, they have been used to evaluate the effect of a large number of public intervention in education in particular, but not only in education. And the RCT is particularly suited to the case of pilot policies. The pilot policies is a small-scale intervention, a sort of lab intervention, so to speak, put in operation to understand whether the intervention works. And in case you discover it works, then you can scale it up to the entire population. So it is a tool to answer the question, does it work? So since you have this question, it means that you don't know, of course. But if you don't know, there's less room for ethical concerns. Remember, when you randomize, you are denying something to some individuals. So there might be someone waving the hand, okay, you are denying something potentially useful to those individuals, but the point is that you don't know. The reason why you're running the RCT is precisely because you don't know whether it is useful. So I would say that very often, when you use the RCT for a pilot policy, there's very little room for ethical concerns. An example, a recent example, Arcipelago Educativo is a summer learning program for vulnerable students promoted by Save the Children and the Fondazione Agnelli, implemented in several Italian sites, metropolitan area. The content of the program, the summer program, is approximately 100 hours of educational activities. I'm skipping the details here, just to give you. It has been run in strict cooperation with the schools of the area, and the schools, they provided a list of students in need of learning support. There are approximately 1,000 students in the program, randomly allocated to treatment and control. A baseline survey by the end of the school year 21-22 to collect information on the students before the beginning of the program. And then a second survey by the end of the summer, plus some administrative information provided by the school of those students. There has been a non-compliance problem in this RCT. I'm talking about non-compliance in a moment, but here are the numbers. Only 73% of students assigned to the treatment group accepted to take part into the program. So some of them drop out of the treatment group. I'm telling you in a moment more on this. So here is a sketch of the main results. So according to their experience, reported experience, students think the program has been especially beneficial for making new friends and learning new things. So positive experience, according to what they report. The causal effect for Italian literacy in general are positive and statistically significant. It is a bit smaller and only marginally significant for maths. Especially beneficial to students with special education needs and to primary school students. And here is an interesting picture, because here what you see is the variation in the test score from June to September. And to the left, maths, to the right, Italian, to the left, the control group, to the right, the treatment group. And what you see is that the control group experience some learning loss, both in mathematics and in Italian. So negative variation in test score from June to September. While for the treatment group, what you see is a small gain from June to September. So it seems the evidence, let's say, is consistent with the idea that this program has been effective to counteract the summer learning loss. So more details on Archipelago Educativo tomorrow, research session 15, the paper presented by DATI. Limitation of the RCT. First of all, non-compliance. The problem we had with Archipelago Educativo. So there is a protocol for the RCT setting the rules to be followed by all the parties involved, and then there are things happening in the field. And of course, things happening in the field are not exactly the same as those prescribed by the protocol. And in particular, there's very often, I would say nearly always, I'm sorry, a problem of non-compliance. So some individuals assigned to the treatment group and not showing up, refusing to receive the treatment, the intervention. And on the other hand, some individuals assigned to the control group, strongly willing to receive the treatment and finding the way to get it. So there is a corruption of the original RCT protocol. So the actual status is different, for some of them, is different from the status mandated by the RCT protocol. In the case of Archipelago Educativo, you'll see that only 73% of the treatment units accepted, of those assigned to the treatment, accepted to take part into the program. So what we can do here, which is a key ingredient of the solution, is to compare the overall treatment group and the overall comparison group, control group, as mandated by the protocol. But what you identify, what you estimate in this way, is the causal effect of being offered participation, which is different from the causal effect of actual participation, because in the case of Archipelago Educativo, some of the units in the treatment group, as a matter of fact, did not receive any intervention. So what about the causal effect of actual participation, which is of course the part most interesting? So the way out is very simple. Yes, quite a lot simple. So start from the comparison treatment to control, which is named intention to treat effect, and rescale it to take into account of the percentage of students dropping out of the treatment group. So in the end, it is a very simple ratio there, down to the right, the effect of assignment to T, the intention to treat, divided by the proportion of units assigned to the treatment and actually receiving it. Okay. So this way you get the causal effect of actual participation. So there is a price to pay for the solution, of course. It doesn't come for free. It is an average impact on a very specific subpopulation, because things become even more complicated when there are both dropouts and crossover. So both units in the treatment group refusing to get it, and individuals in the control group finding the way to receive the treatment. So what has been shown in this paper by INVALSI 1994 is that this way you identify the causal effect on a very specific subpopulation, the compliers. The compliers are those behaving the way you hope they behave, you like they behave. So the general lesson here is very simple. In an RCT, the evaluator is doing her best to control who gets what. But the evaluator is not the only player in this game. There are several other parties involved in the implementation of the intervention. And individuals included in the study, think of the case of Archipelago Educativo, they have the power to defeat, at least partially, the evaluator attempts to keep everything under control. So, and then in that case, which as I told you is very often the case, what you can do is to apply ex post correction to account from the deviation from the protocol. Understanding the mechanism driving the effort. So there is a radical critique of the RCT and more in general of the counterfactual logic. And the radical critique is that all we get out of this paradigm is whether an intervention works or not. But you do not learn why it works or maybe why it doesn't work. And the critique go ahead by pointing out that in the absence of an answer to the why question, why it works, why it doesn't, it is hard to say how to adapt the intervention to different contexts, different from the actual one. Right. So the reply from the counterfactualists is very simple, right? Okay, there is a problem, we agree. But the why question is very often much harder to answer than the whether question. And so, pragmatically, so let's start with a reliable answer on whether there is an effect. First point. And then we search for an explanation of that effect, why there is that effect, or why there is not any effect. So, which, I mean, I'm sure my grandmother would agree. First, be sure of what the explanand is, then search for the explanation. Nonetheless, it is quite often the case to integrate together a quantitative analysis, the counterfactual analysis, with a qualitative analysis. By qualitative analysis, I mean the following. So interview a small sample, interview literally, open interview, no statistics here, a small sample of the treatment group, to explore question of how and why certain results were attained. So give voice to the treated units. Listen to them. Ask them about their own experience, which might be a way to get unexpected insights on the process that led to the success or failure of the intervention. So here is the case of Class A 2.0. It is a pilot project providing ICT to a sample of a junior Italian high school. And the main finding of the counterfactual evaluation is summarized there. So the impact on student achievement, as measured by the usual test score, is small, confined to the most disadvantaged students, and only on literacy score, nothing on maths at all. So an external observer visited some of the treated classes by the end of the last year of the program. So it is the third year of the junior high school. And according to the report of the external observer, the degree of cooperation between students in the Class A 2.0 was much stronger than in standard classes. So which likely to result in a net gain for the weakest component of the class. So according to the teacher's report, the ICT they used during the 3 years was an extremely powerful tool to integrate words, images, sounds in a stable reservoir available to all students of the class. So again, this is likely to result in a benefit for the weakest part of the class, because the other students presumably would have been able to find their way even in the absence of those resources. And so, I mean, skipping some part because time is running too fast. But this is just the idea of how to integrate the quantitative, the counterfactual evaluation with the more qualitative information. So the end point of the RCT. So here is an extreme case. You will remember the pandemic period, I'm sure. And this is about the RCT to test the efficacy of the COVID-19 vaccine. So phase 3 of the trial ended in the beginning of November 2020. So immediately after that, the developer asked for permission to deploy the vaccine under emergency use in the US. Immediately after that, also in Europe. But once a vaccine is granted an emergency approval, of course, there is pressure to offer it to everyone willing to receive it. In particular, you cannot deny the vaccine to individuals included in the control group. If they want to get it, it would be highly unethical to deny the vaccine to them. But this way, you are destroying the RCT protocol. So here is the vaccine dilemma. So there is a dramatic tension between using the vaccine as soon as possible, you remember well why, versus learning more on the long-term effect of the vaccine. If you destroy the RCT, you cannot use the RCT to estimate the long-term effect of vaccinating the population. But even in far less extreme, this is an extreme case of course, but even in far less extreme case, it is very often the case that there is an endpoint at which the experimental data are collected. For instance, because there is a funding body providing the money for the experiment and willing to receive a report on the results within a pre-specified span of time. And the endpoint, I'm sorry, might be too soon to fully appreciate the effect of an intervention. So there are solutions, I'm skipping here because of time, combining the experimental design with the observational design. They're clever solutions, but the key point is that they are solutions requiring more than the ingredients of the RCT. Observational studies. What if one cannot run an RCT? So think here, for instance, this is a quote from Mostly Harmless Econometrics by Anglist and Pishkin. So it is clear that you cannot evaluate using an RCT the effect of immigrants on the economy of the host country. There's no way of doing that, of course. Still, that is a super interesting policy question. Okay. So the target here, when you cannot run an RCT, the target is exactly the same as in the RCT. We should be able to find a pool of individuals not exposed to the intervention and providing a credible approximation to the counterfactual of individuals exposed to the intervention. And the constraint here is sharp. The evaluator cannot decide. The evaluator can only observe what happens in the real world, only. So think again of the case of the COVID-19 vaccine. After making the vaccine publicly available, December 2020, there is no way to run an RCT to evaluate its effects on hospitalization and on mortality. So all we can do, the only way out, is comparing what happens to people choosing to take the vaccine and to what happens to people choosing to avoid it. But the two groups are clearly not randomly selected. Here is a paper providing some answer to this question, but I'm skipping it again. So, I would say the most intuitive observational solution is controlling for observable characteristics. So here is, the logic is very simple. If the RCT is unfeasible, do your best to ex post mimic it. So the key point of the RCT is that the two groups are equivalent with respect to everything but exposure. So make the two groups as similar as possible with respect to what you can observe on them before the beginning of the intervention. we force, literally, the two groups to be as similar as possible. Here's an example from Trentino, not college. It is a training course, post-diploma training course, targeted to 2029 unemployed individuals with high school degree. So the eligible individuals had the option to participate and freely decided. So it is clear that they are not random, no random selection here. And the comparison group is made up of individuals living in the same place, same level of education, same age, same labor force condition, unemployed. But of course the problem is that non-participants, the question is, are non-participants truly comparable to participants in those training groups or not? And here, the way out is that from an administrative archive, we get information on 3 full years of pre-intervention labor market history for all those individuals. A detailed description of the labor market history of those individuals in the 3 years before the beginning of the course. And what we did is to select among non-participants only those most similar to participants with respect to their pre-intervention labor market history. So I'm skipping the statistical procedure to implement this idea, that not really important here, but here is the key picture to it. So 0 here is the time at which the program starts. So 3 years before and approximately 27 months after the beginning. The dashed line is the control group, and the solid line is the participants. You see that they are more or less the same in terms, this is the monthly employment rate. They are more or less the same in the 3 years before, and they are more or less the same because we force them to be similar, okay, by selecting only non-participants with the same pre-intervention labor market. And then there are the monthly employment rate in the 27 months after. And what you see is that in the month 0 to approximately 10 after the beginning, the employment rate is larger for non-participants. And the explanation, of course, is very simple. Participants were attending the course. They could not work. So this is the lock-in effect, no surprise. But starting approximately from month 10, it is clear that the employment rate of participants is 10 to 15 percentage points larger as compared to the employment rate of non-participants. So the key difference between RCT and this strategy is very simple. In an RCT, the two groups are equivalent by construction with respect to everything, whether observable or not. When we implement this idea, the two groups are on average equivalent, but only with respect to what we can observe. In principle, there could be something else we do not observe, with respect to which the two groups are not equivalent. Okay, so this is 45 minutes, right? Okay, so I'm running fast on some issues here. So I'm skipping the part on regression discontinuity design, which is a special case in a sense. A few words on difference and differences, which is possibly the most ancient idea here. So suppose you have two regions, region A and region B, bordering. And starting from a specific school year, a reform is introduced in schools of region A. Could be, for instance, extra time at school in the afternoon. So this extra time is available for schools in region A, but not in region B. But in addition, here we observe the student's test score, average student test score, over several school years, over time, both before and after. And here is the representation of what is happening. So the green line here is for the treatment group, the red line is for the control group. And what we see is that 0 is the point in time in which the reform is introduced. So to the left of 0, we have pre-intervention periods. And what we see here is that there's a clear difference between students in the treatment group and students in the control group. It's larger here than here. And that difference, of course, is not due to the intervention, because in the pre-intervention period, there is no intervention. Okay. So what we see is that they are different. But the other thing we see here is that that difference is stable over time. So the test score of students in the two regions is evolving over time along the same trend. So what you can do here is take the pre-intervention trend of the treatment group and project it forward. So what we are doing here is that if the two lines are parallel before the beginning of the intervention, they would be parallel in the absence of the intervention. So the dashed green line provides the counterfactual for the treatment group. What would have happened in the green schools, in the green region, in the absence of the intervention? And then all you have to do is to compare the solid green line, the factual for the treatment group, to the dashed green line. This way you end up with an estimate of the causal effect. So the key point, of course, is this condition I told you before, this idea of common trend. Even if the level is different in the two regions, the evolution over time is along the same trend. Final remarks. 2 points on this. First one is on privacy. So it is clear that since we are working with data on individual data, not aggregate data, there's room for intrusion in the privacy of the individuals included in the study. So the main challenge for research, for people doing not only counterfactual evaluation, but in particular for people doing counterfactual evaluation, is to use the data for the research purposes and at the same time protect the personal privacy of individuals involved in the study. And the key principle here is informed consent. People must know in advance what is going on. We have to explain them what we are doing, why we are doing, and the reasons why they should not fear any disruption of their privacy. And to me, the key point to me is here. The key point we should explain to all the parties involved. So we do not evaluate the performance of schools, teachers, students. We evaluate the effect of the intervention. This is the key point. So the identity of the subjects involved in the study is not the target of the analysis. In the final report of a counterfactual evaluation, there's no need to write down this guy got this score. What we do is to provide an average outcome for individuals receiving the treatment and the average outcome for individuals not receiving the treatment. So there is no risk of disclosure of the privacy because there is no need to disclose the privacy. This is the key point to me. The final point is the one I started from. The key word in counterfactual evaluation is design. So this is the simple sketch of the timeline of the operations. So you start with the design of the intervention, and at the same time you start thinking of the evaluation of the intervention. Next step is the recruitment of participants and inform them and get informed consent from them. There's typically a benchmark survey before the beginning of the intervention to collect information on all the individuals involved in the study to have a starting point for each of them. Then, in case you are able to randomize the assignment, this is the point in time in which you do the random assignment. Then there is the intervention period, which might be very short or very long. It depends on the nature of the intervention. And then the final, the end-line survey, in which you collect the information on the outcome, the information to estimate the causal effect. So depending on the complexity of the intervention, it might take several months to deliver the whole system. I mean, if, for instance, if the intervention period is as long as 1 school year, so from the beginning to the end could be something like 24 months, at least. Okay. So the design of the evaluation goes hand in hand with the design of the intervention. Don't think about the evaluation after the end of the intervention. It is the right way to get nothing. So this is, you should start thinking about it from the very beginning, because this way you minimize the risk of discovering, when it is too late, that one piece of relevant info, relevant for the evaluation, is not viable. So all parties involved in the study, in the project, fully informed in advance. The intervention is taking place to discover whether the intervention works. Careful training of people in charge of all the field operations. Careful evaluation of whether the RCT is available or not. There might be political constraints such that you cannot randomly allocate the intervention. And finally, collection of all the information at the right time. This is my last slide. So, how do we observe the unobservable, counterfactual? So it is clear that if you can go RCT, there's no doubt it is the safest way to end up with a credible estimate of causal effect. But the point is that you should be ready to go observational for at least 2 reasons. The first one is that even if you are going RCT, it is clear that something will happen in the field, at least partially disrupting the RCT protocol, in which case you need to add an ex post correction to end up with a meaningful, even if originally you randomly allocated the intervention. In the end, you need to implement some observational tricks to correct this departure from the protocol. Point number 1. Point number 2, even more important to me, there are lots of interesting questions on public policies and much less opportunities to run RCT. So there's no reason to avoid the answer to those policy relevant questions only because we cannot implement an RCT. And in that case, it is clear that the only way out, feasible solution, is an observational study. So, more important than the distinction between RCT and observational studies, more important than that, is designing in due time the counterfactual evaluation. That's it. Thanks.